Hello, I'm Professor Rathod. Now I am going to present on the topic of boiler draught. Boiler draught. What is a boiler draught? What are the objectives of boiler draught, and what is the need of boiler draught? Now, what is the word boiler? As we know, boiler is a steam used for power generation, process heating, and for many industrial processes. To produce the steam at a required pressure and temperature, boiler is used. Boiler are also known as steam generator. Now we know boiler is a closed vessel made up of high quality steel in which steam is generated from water by application of heat. Water receives heat from hot gases through the heating surface of the boiler. Now the steam generated is collected over the water surface. Now this is the definition of the boiler, we can say. Now what is exactly the topic is boiler draught. Now what is boiler draught? Boiler draught is a small pressure difference which is necessary to draw the required quantity of air for combustion and remove the flue gases out of the boiler combustion chamber. So this is the small pressure difference which can cause the combustion is taking place, and the burnt gases should be goes out through the chimney to the atmosphere. That is what is now the main objectives for draught in boiler is to provide sufficient quantity for combustion, to expel out hot gases to flow through the system, to discharge these gases to the atmosphere through the chimney. Usually the draught is nothing but a pressure difference of small magnitude and is measured in of water column by means of draught gauge or manometer. That is about the boiler draught. Now exactly one of the definitions given: draught is one of the most essential system of thermal power plant which supplies the required quantity of air for combustion and removes the burnt products from the system. Boiler draught. Now there is a definition. As I told, the draught is necessary to force the air through the fuel bed or grate to aid in proper combustion of the fuel and to remove the products of combustion. So that is it means the flue gases to the atmosphere after they have given their heat to water being evaporated in the boiler. Draught also provides the velocity of the flue gases and so increase the heat transfer coefficient of the boiler. Thus, draught is essentially required in a boiler and can be produced by the number of methods. So you can see the boiler draught are divided basically in two types. One is natural draught, another one is artificial draught. Artificial draught is again divided in mechanical draught. Mechanical draught is again divided in two or three types. One is induced draught, another one is forced draught, one more we can say a balanced draught, and artificial draught, steam jet draught. So these are the types of boiler draught. Now the next, the draught, we can say the natural draught and mechanical draught. As I told you, natural draught, the draught required for the flow of air and gas inside the boiler is created by the chimney alone. Now we will see under the mechanical draught, forced draught, induced draught and balanced draught. We will see to the next slides. Natural draught is obtained naturally by the use of chimney. Chimney is a conical shape, vertical, tubular, steel or masonry or concrete structure having a large height. The flue gases, after transferring their heat in the boiler, are guided by chimney to a considerable height in the atmosphere. As chimney has a large height and is the only outlet from boiler, it remains filled by the hot flue gases. So this is the information you can able to read from this PPT all about the natural draught. This is also the natural draught. This pressure difference called the natural draught because it is produced not naturally. So in this way we can explain. So exactly the natural draught, as I told you, the natural draught is obtained by use of a chimney. The chimney in a boiler installation performs one or more of the function, we can say. It produces a draught whereby the air and the gas are forced through the fuel bed, furnace, boiler passes and the settings, and it carries the products of combustion to such a height before discharge them that they will not be actionable or injurious to the surrounding. Chimney is a vertical tubular structure built either of masonry, concrete or steel, as I told you. In this, the draught produced by the chimney is due to density difference between, you can see the column of hot gases inside the chimney and the cold air outside. Now we can actually able to define it. You can see the grade level, then the column of height of the chimney, that is denoted by H, then the chimney, then the boiler, then the column of cold atmospheric air, then the equivalent column of the hot gases, you can able to see in the diagram. So now as I told you, so if we have the relation, that is P1 is equal to PA plus rho G into GH. Now P1 here is pressure at the grate level, chimney side, and P2 is equal to, we can write PA plus rho A into GH. Now what is P2 here? Again, pressure acting on the grate on the open side. Now rho A, that is the mass of density of air outside the chimney, and rho G is the average mass of density of hot gas. Now therefore with relation of P1 and P2, what important in this, what you have to calculate, though I have not written here, but I can explain you. Net pressure difference causing the flow through the combustion chamber, that is delta P, that difference in P is equal to P2 minus P1. Therefore I can write the equation with the both of the equations into bracket rho A minus rho G into GH. As we know, the rho, as I told you, rho A, that is nothing but density of air outside, the mass of the density of air outside the chimney, and as I told you, rho G is the average mass of density of the hot gas. Then what is actually GH, small gh, small gh, that is the pressure due to the column of hot gases of the height h meters, and the pressure exerted by column of cold air outside the chimney at the height capital H, that is in meters. So this is all about the natural chimney. Important in this is the difference of pressure acting the flow of gases is known as static draught. Its value is small and generally measured by, as I told you, generally measured by water manometer. What is artificial draught? Artificial, when the draught is produced by some external agency, that is mechanical, fan or blower, or by steam jet itself, it is called artificial draught. In the modern commercial boilers, more value of the draught is required to increase the heat transfer coefficient and hence the thermal efficiency. So artificial draught is must to use to overcome the flow resistance offered by the large flue passage. So again, the classification of the artificial draught: forced draught, induced draught and balanced draught. We will see one by one. The next one is what is forced draught. Forced draught is a positive draught, pressure draught. positive pressure draught. The fan is installed at the base of the boiler before grate, which forces the outside air through the flue bed, furnace and air preheater, and then flue gases through flue passage, economizer, etc. etc. The enclosure for the furnace has to be very tightly sealed so that the gases from the furnace do not leak out in the boiler house. So the force draught, we can able to see the fantastic diagram of the force draught. You can, what is important is the role of blower. It is placed near the bed of the boiler. You can see the boiler, furnace, grate. From this the gases, flue gases goes to the economizer. In the economizer, that there are number of tubes. So due to the flue gases, that water inside the tube gets hot, then it goes to the air preheater. In the air preheater, if the fresh air is goes through the air preheater, that air becomes hot. So economizer and air preheater are the boiler mountings that plays its corresponding roles. But in this case, the draught force is applied to whatever the flue gas created inside the furnace of the boiler, that goes through the economizer, through the air preheater, and then it goes to chimney or the stack to the exhaust, that it released into the exhaust. So that is the importance of the force draught. Now what is induced draught? In this system, a fan or blower is located or near the base of the chimney, which creates the partial vacuum in the furnace and flue passage. Thus, the air and flue gases are drawn through the boiler due to comparatively higher pressure of outside air. If it is convenient to produce induced draught, and like in forced draught, any type of fan or blower may be used. Now the important diagram of the induced draught, you can able to see the position of blower is important. Now the blower is placed near the base of the chimney, so that whatever the flue gases given to the chimney, so from the furnace, the whatever the gases that comes into the economizer, then goes to the way of air heater. Like how, so induced, the flue gases is induced through the boiler, and then it is pressurized, or it is supplied to the chimney or the stack through the chimney, then it is released to the atmosphere, the exhaust gas, whatever. What is a balanced draught? It is a combination of the forced as well as induced draught. Forced draught fan overcomes the resistance in air preheater and the grate. Induced draught fan overcomes draught losses through the boiler, economizer and connecting flue passage, etc. Depending on the type of fuel burnt and the type of boiler, the fan or blower used may be any type as a radial or axial, etc. Now we will see the diagram, see the position of the blower or the fan, how it is called as mechanical. As the blower or the fan is used, one of the blower is used at the near the boiler, that is base of the boiler, and another one is located near the base of the chimney. So first one forced to the furnace, then it goes to economizer and the air preheater. Then the second one induces all the flue gases created inside the bed of the system. Then it induces, and then it allows to flow into the chimney. In the chimney, inner side is hot flue gases, outsider is the fresh air, so that the small pressure is created inside the chimney, so that the hot flue gases go up and up. So that is exhaust gas goes to the atmosphere, so it will not be hazardous to the human beings and the crops and the animals. So one of the mechanical uh, draught is named as steam jet draught. Now what is actually the steam jet draught? It is a simple and a cheap method of producing artificial draught. In a steam jet draught, the exhaust steam from a non-condensing steam engine is used for producing draught. It is mostly used in a locomotive boiler, where the exhaust steam from the engine cylinder is discharged through a blast pipe placed at the smoke box and below the chimney. In induced steam jet draught, steam jet draught, the steam jet issuing from a nozzle is placed in the chimney, but in a forced steam jet draught, the steam is issuing from the nozzle is placed in the ash pit under a fire grate of the furnace. Now this is the steam under pressure is available in the boiler. Now this is a high velocity steam carries along with it a large mass of air or the flue gases and makes it to flow through a boiler. It is, as told you, it is a simple easy method producing artificial draught without a need of an electric motor. So steam jet is creates some vacuum inside surroundings, so attracts the air of flue gases either by carrying along with it. Thus it has capacity to make flow of flue gases either by carrying or inducing towards the chimney. Flue gases, the burned gases that shall be goes to the chimney. Now you can see the diagram. So the exhaust steam from the steam engine, from the bottom it enters into the equipment of the steam jet, and from the right side or the another side hot flue gases which goes into the steam jet draught, so that a small pressure is created inside of it and the exhaust steam and flue gases goes out, that you can able to read from the steam jet draught as I explained you earlier. Now there are some of the advantages of the mechanical draught. Why the mechanical draught is important? It is more economical and its control is easy. It increases the rate of combustion by which the flow great fuel can also be used. It saves the energy, and heat of flue gases can be best utilized by it. So again there are some disadvantages. Maintenance cost is also higher. Initial cost of the mechanical draught of the system are high. Noise level of the boiler is also high due to the noisy fan or blower, etc. So what are the draught losses? Now the what are the reasons of loss, or why the loss is occurred, why the loss is taken into account? A loss near the bends in the gas flow circuits, loss due to imparting velocity to the flue gases, the frictional resistance offered by the flue gases and gas passes to the flow of flue gases. Now the loss due to frictional head in equipment like grate, economizer, superheater, etc. Thus loss in draught in a chimney is around 20% of the total draught produced by it. The loss due to flow resistance offered by the chimney, loss due to bends, as I explained, loss due to frictional resistance, etc., etc. These are the losses. So around the 20% of it is now one of the next important bit I have considered in it, efficiency of chimney. Efficiency of the chimney, it may be defined as a ratio of energy required to produce the artificial draught. The draught is expressed in meter head or joules per kg of the flue gas to the mechanical equivalent of the extra heat carried away per kg of flue gases due to the natural draught. Now here also you can able to see the ratio of the energy required to produce the artificial draught to mechanical equivalent to extra heat carried away per kg of flue gases due to the natural draught. Now let us h dash is the height of flue of the column of the artificial draught. Now T2 is the temperature of the flue gas in the chimney with the natural draught, that is measured in K, that is Kelvin, absolute unit of the temperature. Now capital T is the temperature of the flue gases in the chimney with artificial draught, that is also measured in K, that CP, that is the specific heat of flue gases, that is measured in kilojoules per kg of K, and it is considered 1.005 kilojoules per kg of the K. So the chimney, the efficiency of chimney, I'll state now how the efficiency of the chimney can be stated on the basis of mechanical equivalent of the extra heat carried away, that is given by 100 Cp minus T2 minus T1. As I told you, Cp is the specific heat at constant pressure, T2 as I told you, that is the temperature of the flue gases in the chimney with natural draught, and capital T, that is temperature of the flue gases in the chimney with the artificial draught in K. Therefore finally efficiency of the chimney can be written as H dash G divided by 1000 Cp T2 minus T1, or here it can be mentioned in the form of 9.81 H into bracket, you can able to see M into Tg divided by M plus Ta minus 1 divided by CPG, that is specific heat at constant pressure of the gas, into bracket Tg minus Ta, that is temperature, Tg is temperature of gas, T2 as I told you, that is the temperature of the flue gas in the chimney. Like how T2 is given, the temperature of the artificial draught it is given. So finally this is the efficiency, you can able to see, that is another way it is given H dash G divided by 1000 Cpg into bracket T2 minus T1. So you can able to see in the chimney draught the efficiency, if always less than 1%. So this is all about your efficiency of the chimney. Thank you. So whatever in this boiler draught, what is boiler draught, what is the importance of it, what are the advantages, what is the draught losses, efficiency of chimney, so I'll close here. Thank you.